Hello to the HEAD community. My name is Erin Kara, and I am the Deputy PI for Science of the AXIS mission. First off, what is AXIS? It is a relatively simple design. It's a high spatial resolution X-ray optics in front of a CCD camera. I like to think about AXIS as the successor of Chandra ACIS in that it has a very good imaging capability, 1 arcsecond requirement and 2 arcsecond threshold. But what's different about AXIS is that it has that great PSF over the entire field of view. So over that 28 by 28 arc minute field of view. It has a very large effective area, 10 times the effective area of Chandra ACIS at launch. It's also, you can think about AXIS as a successor to SWIFT in that it has fast slew capabilities. It'll get on source with less than 4 hours, just like SWIFT, but it also is 100 times more sensitive than SWIFT. So in this era of multi-messenger astronomy and time domain surveys probing larger volumes, we need something that's fast and very sensitive in X-rays. AXIS also has a very low particle background, and that's going to be essential for studying things, diffuse emission from things like supernova remnants, galactic winds, clusters of galaxies, etc. So the reason that I am really jazzed about AXIS is that because it's going to do a wide range of science. It has a lot of breadth, and it also meets the science goals of the identified in the Astro 2020 Decadal Survey. So Astro 2020 had these 3 science pillars for worlds and suns in context. AXIS has this great field of view, very sharp PSF, that it's going to be able to measure stellar flares, even in very crowded fields, to understand the role of X-ray heating, X-ray radiation, high energy radiation in exoplanet atmospheres. And this is essential for understanding habitability in those exoplanets that we're finding. In the realm of new messengers and new physics, AXIS is going to find the electromagnetic counterparts to multi-messenger events. It has this great big field of view and is very sensitive, and so it can quickly slew to a LIGO or an ice cube or a LISA error circle and quickly tile that region to find the EM counterpart. In the context of cosmic ecosystems, there's so much that AXIS can do. Just highlighting one science that's especially exciting is that AXIS has the sensitivity to do very deep high redshift surveys, and it'll essentially find like all of the AGN that are radiating at above a luminosity of 10 to the 42 ergs per second out to a redshift of 7. So really getting at that question of where do supermassive black holes come from and how do they grow and evolve over time. So AXIS has this amazing spatial resolution that very beautifully complements the high spectral resolution and large effective area of Athena. And so it's very complementary, just like Chandra has complemented XMM Newton all of these years. So you're probably thinking to yourself at this point, like, this mission sounds awesome, Erin, but can you actually do it? Of course, that's the big question, and AXIS's real breakthrough has been in the development of these lightweight single crystal silicon optics, and the work is being done in the lab, continues to progress over time. We know what we need to do to get down to that requirement of 1 arcsecond for several mirror pairs by the time of the proposal deadline. And if we continue the progress that we've done, that we've shown with single pair modules, as you see on the left here, if we continue that same rate of progress with 5 pair modules, then we will meet that 1 arcsecond requirement by the time of proposal submission. So I hope that you've gotten excited about Axis in this short spiel. And really, I think the main take-home point is that there's so much science that Axis can do, and we've only just scratched the surface. So we're looking for your ideas. We want you to get involved. Please follow this QR code that you see that will take you to a link to sign up for our science working groups. And we're going to meet regularly to discuss and talk about Axis science. We're also introducing the Axis seminar series, a monthly virtual seminar series. We want to specifically looking for early career researchers, the people who are going to be around to use this telescope, about the fun science that they are doing. And if you want to hear more about Axis, please join us tonight. We have a splinter session from 6:30 to 8 p.m. if you want to hear more about Axis science and the technology development. Thanks so much for your time.